Hello and welcome back to Precalculus 1. There we go. Section 1.3 on basic functions, more on functions, graphs, domain, range, all of that cool stuff to end the talk on functions. So first we are going to look at basic shapes which you will have to memorize, and we will build on those shapes later on in the course. These are listed on the cover of your textbook. You know how there's a hardcover? So first or the second page, either on the front or the back, we'll have these functions listed and drawn. But let's go and start with the number one constant function with the formula y equals some number c. Y equals 2, y equals negative 10, whatever. That is the horizontal line going through number c. So it's going to look like this. That's the function. Just this horizontal line going through c. It's called constant function because it doesn't change its y value. It just plows straight through. Number two is the one that you already know, linear function. Y equal mx plus b. And you know that's some kind of a slanted line. It could be positive, could be negative, right? It goes through value b, which is the y-intercept. So you already know all about these two. You might know parabola. That's a quadratic. And that's going to be your good old y equal x square or y equal ax squared plus bx plus c, depending on how spicy is the case that you have. Now, the basic y equal x squared is that U-shaped graph. And we are going to have the whole chapter deal with these, what we call polynomials, so on. Number 4, cubic function. That one in its original, before I do that, y equal x cubed. And its original graph is this squiggle that goes through the origin like that. Then there is also fourth power, fifth power, sixth power. It's called polynomials. That's for chapter 2, so we don't have to worry about those now. The next one that you will have to know right now is the square root of x. So that's called radical function, which is y equals square root of x, and that one starts at 0, 0 and just rises towards positive y. Two more for the basic list, and by the end of the course we will add another two. 6 would be rational function. Y equals 1 over x is the basic one that you are memorizing. Spicier examples will be in 2.6 later on in course. So we just need to know the 1 over x basic graph, which is following these x and a y like this. Right? The last one is absolute value of y equal absolute x. Now, absolute value can be applied to anything, but we're just using it now in the first course on x. In calculus, you will find absolute value applying to any other function. We are only focusing on this, and it's going to be a V shape. So 45 degrees straight line going up. Hopefully that makes sense, because the X, right, whatever X you plug in, whether it's positive or negative, should spit out the positive Y, and you see that both of these lines return positive Y values. Now, before we go on, I have to talk about reading the graph, just to make sure that everyone is on the same page. Way to read the graph. This course will have a lot of graphs. It sets up stage for calculus that has a lot of graphs. Graphs are a preferred way for everyone to read information. It is much easier to see visually increase or decrease when you look at the line, whether it goes up or down, rather than sort through insane amount of data points and then figure out whether they go up or down. For instance, if I look at the graph like this, I don't know what its formula is, but I know that this graph is increasing, because the Y values are rising as you are progressing forward in X. A graph like this would be decreasing, because as you are progressing in X to the right, the Y values are dropping. They're dropping down towards 0. We know that the Y-axis is the one that has 1, 2, 3, 4 going up. So you can see that these values 1, 2, 3, 4, 5, 6 on Y are rising as X goes, because here is 2, and then over here is a 3, and over here is 4, and over here is 5. So as you are going further and further along in X, you see that the Y values are climbing constantly. It is much faster to look at the graph and see, oh, line is going up, line is going down, to spot that, than to actually look at the data, which are the ordered pairs, and then go from there, especially if you have 100 points available and you have to look at all of them, right? Now, in order for you to read a graph, you need to go up or down in X coordinate and bounce off of the line to the Y coordinate to read the value. So if let's do the cheapest case of a linear line. So here is some arbitrary linear line. Let's go. There we go. So for this linear line, I can see that over here, when my X is 4, as I go up to hit this point, it bounces back into Y equals 3. So this ordered pair is 4, 3 as a location on the graph. So now I have that, 4, 3. I also have that it goes through 1 on the Y-axis. And I can use this information to calculate the line. This is the next section that reviews, it's not a part of Precalc obviously, which reviews your linear lines. So 1.4 and 1.5 are talking about linear lines and slope and all of that stuff you covered twice in algebra, elementary algebra and intermediate algebra. Since we are not having those sections, I'm just going to, do it here real quick. So I already have that the line cuts through 1. Line cuts through Y equals 1. which means b equals 1 for y equal mx plus b. So I already know y equal mx plus 1. I already know that. Now I have the other point, 4, 3, and that's my x and a y. So I just now plug in, and I can calculate m quickly. Y is equal to 3, m is unknown, x is 4 plus 1. Move 1 to the other side, 2 equals 4m, m equals 1/2. So y equals 1/2 x plus 1 is the equation for the linear line on the picture. So this is a skill from algebra class that is assumed you have here, right? And once you have the graph, and this is why the square paper is important, because you can pick up where the values are. You take a look at this, right, and you get your equation of the line going through. We see the positive slope, positive 1/2, because the line is rising, it's increasing. It's a straight line, so it's y equal mx plus b. So all of those features. But it's very important to understand that if you want to find the values on the graph, you will have to go to the line and bounce it off into the y to read the number off of it. And if there is no line, that means that the function doesn't exist there, therefore there is no y, because you can't get to it. Let me give you an example of the square root of x. So this is one of the functions that you just learned what a shape is if you never knew it before. I did tell you that you are starting at 0, 0, and then you just have curve quickly up and then turn. It will still grow forever. Don't make it flat. It will still grow forever, but it will start growing slower and slower and slower. It's a sluggish function. Grow slowly. So what do you know? You know that square root of 1 is equal to 1. Do you have that feature on this graph? Well, you do. If you drew this appropriately, you will have 1, and when you go up, it will bounce off and it will return 1 on the y-axis. That is how you read graphs. You go up or down on the x coordinate that you are interested in, and it has to hit the graph somewhere, and it will bounce off into a y on that elevation to give you the value. Now you also know that square root of 4 is equal to 2. 4 is here, and now I see that my graph is not too good because the graph should be going through this point, right? So it can bounce off into 2. So I can fix this graph. Has to go through 1, 1. Has to go through 4, 2. So it should be something like this. So this point is 4, 2. This point is 1, 1. If you have issues seeing that, then just do this. Can't miss it, right? So your job is to go from the number on x-axis that you are interested in. You go tap, 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 all the way until you hit the line, and then you go over and you read the number given to you on the y-axis. So you can see that the square root of 4 is 2, not just from calculations, but also from the graph. They have to match. Now, what I wanted to say is that for square root of x, you cannot compute square root of negative 2. If you are to go to negative 2 and then try to find the function above, you can go up forever, and you will never find the function to bounce off of it into the y-axis. And then you can go down forever in search of a function, and you will never find to bounce off and find the y value. Function does not exist to the left of 0. Therefore, the y values do not exist for any x value you pick left of 0. Now, we also know that we can't find the y value for negative numbers, right? So this is not real. Sometimes your professors, instructors in algebra class allow you to write no solution or impossible or something like that. Well, no. The answer for this has a solution, but it's imaginary number. All right? We will cover that in chapter 2. So, for us, we just say not real. Not real meaning it's an imaginary complex number, but the solution exists. It's just that we are not considering it now because we only want real solutions. So we'll get back to that when it's time in chapter 2. Now, this is something that opens the new can of worms called the domain and range. Domain set of all possible x input possible, I'll put allowed, input values. So if you are considering functions like y equal mx plus b, if you are considering x squared, if you are considering x cubed, if you are considering absolute value of x, any x is okay to plug in. They will all return the values in these functions. Think of any x that you want to plug in x squared. Right? You can't break it. You can't break x squared, no matter what you plug in. Do you want to plug in 7? Answer is 49. You want to plug in negative 2? Answer is 4. You want to plug in 0? Answer is 0. Any number, you want a half? It's a quarter, right? 0.6? 0.36, right? So any value that you plug into those guys over there, you will always have, right, the answer. So because of this word, any x works, we say domain is all real numbers. And notation is, you can either put this capital R with a double bar on the capital bar, right, on the side, or you can say negative infinity to positive infinity, right? So that's another one of the notations. So to denote all real numbers, you can either put negative to positive infinity, or you can put double bar R. They mean all real numbers. That include counting numbers, integers, 0, square root of 2, so rational, irrational, right? All of the numbers, fractions, right? That's rational. So all of the numbers. And then we have situations where either one or couple of numbers are not allowed, or even infinitely many numbers are not allowed to be plugged in. They will not return the y value. Here are some examples of that. If you take the function f of x is equal to 1 over x. You take that function. What value is not invited to a party?
0.
Yeah. Why? Beautiful. Why? I'm not like a 2-year-old now. Why? Undefined. Why? So I can give you a little story on why you can divide by 0, but technically when you are dividing, guys, you are making piles. If I had the cake, well, I'd eat it, obviously, but if I had the cake and say I want to share with everyone in the room, right? I would divide that cake by how many people want the slice, right? So if I have 5 people, I will make 5 piles. Fair? Now, if I have 3 people, then I will make 3 piles, and everyone's pile is bigger because in dividing the same cake, instead of the 5 piles, I'm dividing in 3 piles, so everyone gets more, right? Now, so now you understand why the Joker kills the bus driver, right? Okay, good. So the next part is when you are dividing by 0, you are trying to divide a cake into 0 piles. That physically makes no sense. Cake is already 1 pile. Pile of cake, right? You piled all the stuff up to make a cake. So now you have 1 pile. And you are trying to divide that 1 pile into 0 piles. It makes no sense. That's why you can't divide by 0, right? Makes no sense. So, because we cannot divide by 0, we have a problem like this that will exclude 0 and include every other number. So, domain and questions on domain will never leave you. Precalc2, Calc1, Calc2, Calc3, differential equations. These questions on a domain, technically, entire chapter 1, every concept, never leaves mathematics past Precalc1. All of those concepts you will constantly use. Domain. All numbers from negative infinity to 0 are cool, united with all of the numbers between 0 and positive infinity are also cool. Notation. Interval, parentheses, do not include end points. Interval, brackets, include end points. There is a huge difference between writing an interval 0 to 1 and 0 to 1. They both have infinitely many points inside, but the one on the left does not include 0 and 1. The one on the right includes. These are called open intervals. These are called closed intervals. And you can also have them mixed. They're called half open or half closed. And if you want an ancient funny word, clopen. No one uses clopen anymore. The last time I heard is from one professor at Montclair who, since I took the classes there, long time retired. Right, he was already old at that time. He was teaching the class. That was the first and the last time I heard clopen. All right. So, but half open or half closed. So you have up there open intervals, which means 0 is not included. Now, before you ask, Can you just go to 1 and use the bracket? No, because that would exclude 0.8, negative 0.5, and those numbers are just fine, right? You can divide 1 by 0.5. You're going to get 2. All right? It's okay. So we are only excluding a single number, and if you are excluding a single number, that single number you are excluding, you can use the parentheses, and you are just killing that one number, leaving all the other in. So this is the way to calculate domain. You think in your head and you say, what value would mess the things up? What value would make 0 in denominator, right? And if you figure out what value does that, that's the value you have to kick out and keep all other points in the domain. Let's take a look at another example. Say g of t is equal to 3 divided by 2t minus 6. Is there a value that could ruin our day there? Number 3. Very good. So our domain is all numbers from negative infinity to 3 union 3 to infinity. The only value that we have to kick out is 3, because 2 times 3 is 6, 6 minus 6 is 0, and that's the one we had to kill, right, from the domain. The rest, all fine. Is 0 okay? Of course, right? 2 times 0 is 0. So denominator is negative 6, and if denominator is negative 6, we have 3 over negative 6, that's negative 1/2. It's okay to have a value of negative half, right? So that all works. Let's try another problem. Hopefully this one doesn't trigger anyone. H of x is equal to 4 over x squared plus 1. What's the bad value? Is there a bad value? Yeah. There is no way, comma, in hell, comma, to make denominator 0 here. There is no way. Any number you plug in will be 1 or more. Plug in 0, you get 1. Plug in 1, you get 2. Plug in 10, you get 101. Plug in negative 10, you get 101 again, right? Every single number you try, you are not going to make a 0. So, what is the domain? Beautiful. Also known as all real numbers. You can put that double bar R if that makes you happier. So, to find the domain for rational functions, you can set denominator equal to 0 and find the bad values, right? And then kick them out of the domain. Say you have k of x function, and this function is, let's say, 2 over x squared plus 5x minus 6. Right? Let's say that's it. What you can do to find the domain is you can take this x squared plus 5x minus 6 and set that one equal to 0. You force that one to be 0 to find the bad numbers, and then you kick them out. right? Now you use regular factoring you learned in algebra, right? Whatever factoring technique or you can use the quadratic formula. I don't care. Just do whatever you know. And you have your x plus 6, x minus 1 equals 0, x equals negative 6, x equals 1. So this type of factoring you learned in elementary algebra, then intermediate algebra. So you factor it. Factoring. And now these are, in quote, bad points. So what is my domain? Domain is going to be from negative infinity to negative 6, union negative 6 to 1, union 1 to infinity. Actually, maybe I should, let me just move this. Nice one. There we go. So that's what the domain is. We had to interrupt at negative 6 because negative 6 would make denominator 0. And we also had to interrupt at 1 because 1 would make denominator 0. So set denominator to 0. Other functions, like the square root function, does not have a domain for some values. We cannot take values of negative numbers. So, if I have f of x of square root of x plus 3, and I'm asked for the domain, I'll write in blood. We need to make sure that the argument is positive. Now, what does that mean, argument is positive? Thing under the root is bigger or equal than 0. That's what it means. So to find the domain of square root functions, we go x plus 3 larger equal than 0. You move 3 to the other side. And what this tells you here is that any value bigger than negative 3 or equal to negative 3 is okay. Now we get to use our negative 3 to infinity, our half open or half closed interval notation, because that's what that notation on the bottom means. You can also leave it in that notation. It's fine. So let's test this, right? Let's say you care and you want to check, right? So pick a number between a negative 3 and infinity. 1. 1 plus 3 is 4. Square root of 4 is 2. Awesome value to check, right? Let's pick another number. 0. 0 plus 3 is 3. Can we take a square root of 3? Yeah, with the calculator, we get like 1.73, right? So sure, that works. How about if I put negative 10? Ooh, negative 10 is no bueno, right? What's negative 10 plus 3? Negative 7. And square root of a negative number? Not a real number. Good. Imaginary. Perfect. We will actually do that stuff in chapter 2. Right now, we can just say not real and move on. Right? So to find the domain for any square root function, you take whatever you have underneath and you set it bigger than this. Can you have 1 over 3x there? Yeah. You see, you are not learning example. That is very dangerous. Remember how I mentioned the first day, this is not going to be monkey sees, monkey do like algebra? Algebra class is where you see the example, you memorize the example, and you have A. Pre-calculus, you see the example, you memorize all of the examples, and you most likely fail the class. That's pre-calculus, and definitely calculus. Because what you are learning here is not this example. You are learning the red stuff. Because this could be x plus 3, but it also could be x over 3, 3 over x, could be x squared minus 7. You see that? This is not set to be just x or x plus minus a number. It could be 1 over x, it could be 3 over x, it could be 17 over x, right? In which case, if you don't know this, then you can try and lose on the argument, I have never seen a problem like that before. Well, being that we have more than 25,000 functions, there is a book for it, that means that every concept I teach in red, I would have to run 25,000 examples to show off every variation of the function that we generally use. Right? So no, this is the stuff. The red stuff is what you learn. And you say, I'm applying that. We need to make sure that the argument is positive. Argument. Oh, argument is the thing under the root. The thing. Oh, I missed the end. The thing. I didn't say x plus 3. I said the thing. Whatever you have is going to get. So there is an n missing over here. There we go. Thing. The thing under the square root. So now, if you have any kind of example, like let's say f of x is equal to the square root of 4 divided by, I don't know, 3 minus x. And you are looking for the domain. You are only remembering the red. And you know immediately what to do with the problem. The red stuff says whatever is under the radical needs to be set larger or equal to 0. That's what the red says. And that's what you're learning. So now you don't care what kind of a function. We're going to learn in chapter 3 exponential and logarithmic functions. Right? You set those larger or equal than 0. In Precalc 2, you will learn 6 trigonometric and 6 inverse trigonometric functions. That's 12 new functions there. All follow the same rule, because you can have square root of sine x. That's your Precalc 2. You go sine x bigger or equal than 0. Calculus 2, hyperbolic functions. 12 of those, right? Doesn't matter which math course you take. Red rule applies to 25,000 functions. Not just the one I showed in class. It applies to all 25,000 functions, and I even haven't seen a 1% of those with all of my degrees and years of math, okay? But I don't care because I know that the red rule applies to all of them. I learned the red rule and I don't care about the rest. Because as soon as you write whatever, I know what to do. It's the red rule, not the example. So now, red rule says 4 over 3 minus x needs to be bigger or equal than 0. Okay. Write that there. And now, we need to solve this. Right? So, how would I solve this problem?
Would you multiply both sides by 3 minus x?
Good. Multiply both sides by 3 minus x. And we will get what? Hmm?
4 greater than 0.
4 greater or equal than 0. And that's true. It's true all the time. So now what? Does that mean all real numbers are cool? No. All right? We already see that our method over there, right? You take everything underneath. So now we have to figure out other type of issues, right? We have to split this using the algebra and then use the red rule again. So our f of x, which was 4 over 3 minus x, using algebra, gets split into square root of 4 over square root of 3 minus x. So now what? That is equal to 2 over square root of 3 minus x. Ah, this is where I use the red. See? We use the red up there immediately. It gave us a true statement, but we still know that 7 doesn't work, right? Because 7 would give me negative 4, and then the whole thing under the square root would be negative 1, and I know that negative 7 doesn't apply. So I'm not happy, right? So what I do now is I say 3 minus x larger or equal than 0, and then move x to the other side, which means that x needs to be less equal than 3. You will see now that any value, and holy nightmare, I almost messed it up. I'll write this also in red. It's a trap. Since I need the button, it's a trap. Since 3 minus x was in the denominator, this becomes this because we cannot have equal to 0. I hope that makes sense, right? 3 minus x was in the denominator. Do we all see it in the denominator? So if I say x equals 3, and you pick 3, you get 4 over 0. So we have to kick out that. So the actual answer here is x less than 3. So what's the domain? Domain is negative infinity to 3. That's the domain for this particular function. Now pick any value you want. I don't care. Any value you want from here, you will be able to compute. Pick any value outside of that domain and you will not be able to compute. Pick 4. 3 minus 4 is negative 1. There you go. You already have a negative under the root. Pick 10. 3 minus 10 is negative 7. You have negative again under the square root. Any value bigger than 3 will give you value bigger than, will give you negative under the radical, and the solution becomes non-real. If you pick anything from negative infinity to 3, they become, then you can compute, right? You pick 0, you have 4/3. That's positive 4/3. You just take the square roots. It's okay. And you use a calculator if you can take a square root, right? If it's not a nice number, like a 9, or what else is nice for square roots? 16, beautiful. 4, I saw that, great. What else? What else is nice for square roots? 25, you said 4 already, yes. What else? 36, awesome. What else? 49, 100. 81, perfect. Square root of 81. How about square root of 196? That's 14. 169 is 13. Yeah, 169 is 13. 196 is 14. You just flip them, all right? So 13 and 14, easy to remember those. And then we have 225, 15 squared, 225. Right, so we have the 100, 121 for 11, 144 for 12, 169, 196 for 14, and 225 for, right, those are nice, right, we call them perfect squares. Nice, right, numbers. All right, well, that's what we have for more on functions. I will open the homework so you can enjoy tonight and throughout the week. I'll see you in 2 days. We will cover 1.5 and 1.6 to start at least.